1.5, Summary of Curve Sketching. So there's a few guidelines that they give us, but it's kind of all over the place. And it kind of, which ones you use kind of depends on the problem and which ones, you know, you can look at it. And some of these are going to be harder, are going to be easier to find than other ones. And if it's a different problem, then you're going to have a different situation where something that might be really hard with one particular graph would be easy with another one. So you just kind of have to play it by that way. So some guidelines, first of all, they talk about the domain, you know, try to figure out what the domain is and then go from there. And then, you know, try to, like, if it has like a hole in the graph or something, or if it's got an asymptote or something, or if it's just the restrictions on the domain that are there. Okay, the next one is intercepts. These are the X and Y intercepts. To find the X intercepts, you solve this. You take the function and set it equal to 0. To find the Y-intercepts, you set X equal to 0, okay, to find the Y-intercepts. And these are usually pretty easy to calculate, and that gives you a lot of information about the graph. Okay, symmetry. With symmetry, you have two kinds of functions. You have even functions, and that's where f of negative x equals f of x. And this is symmetric with respect to the y-axis. Okay, so that's a reflection rate of it over the y-axis. And then you have odd functions, and that's where f of negative x is equal to negative f of x. And this is symmetric with respect to the origin. Okay, so we have those. The next one is asymptotes. And you have horizontal asymptotes. And what that one is to find those, you take the limit as x approaches infinity. Okay, or the limit as x approaches negative infinity. So you could have two different horizontal asymptotes. This is also for, like, if you have a slant asymptote also, that's also applies for that. Okay, but horizontal is that's what you look for in the horizontal, what's happening. This could also, if this is like infinity, or that's infinity or negative infinity, then that could tell you, that could also give you the far right behavior and far left behavior of the graph, that information also. And then you have vertical asymptotes. And that's where the limit as x approaches a from the right or from the left or overall, where you get either plus or minus infinity on that one, or from the left, or just overall. And that's what you get. When that happens, you have a vertical asymptote. Okay, and then the last one is intervals of increase or decrease. So the increase is when the derivative is positive, and the decrease is going to be decreasing when the derivative is negative. And again, this is left to right. Okay, so it's increasing means you're going up as you go from left to right, and decreasing means you're going down as you go from left to right. Okay, because if you're going up as you're going from right to left, then that's decreasing. Okay, as you go this way, if it's going up like that, as you go from left to right, that's decreasing. Okay, because you go from left to right, it counts from left to right. Okay, then another one is local minimums or maximums values. And then for these ones, you can like find critical numbers and then plug them in, also kind of see what the behavior is there. Concavity, so concave up is where the second derivative is positive. And then concave down is where the second derivative is negative. And then point of inflection is where it changes concavity. And then sketch the graph, sketch the curve. Okay, so those are just a few pointers on things that can help it that come. And then, you know, as you go along, you can also check other things. You can plot points as well, things like that. Okay, so let's actually do some exercises. Okay, so we have this first exercise, which is f of x equals x times x minus 4 to the third power. Okay, this is just a polynomial function. And so what you can notice off right away is the x-intercepts. Okay, so this is all factored, so the x-intercepts are really easy to find. There's going to be 0, and this one gives you 0, and this one gives you 4. And this one, because this is cubed, this is multiplicity 3. Okay. So you look for these graphs where it goes through 0. Yeah, that goes through 0, and then where it goes through 4. So that could be okay. And then 0 and 4, those are okay. And this is -4, so forget that. And this is also -4. So these graphs are out based on just that information. Okay, and then the next thing that you probably want to look for is what happens as you go to infinity of the graph. And what happens is you go to negative infinity. Okay. So what do we have? We have x times x minus 4 to the third power. Now, if you were to expand this all the way out, your leading term would be x to the 4th. Okay, because there's 1 here and then 3 from here, so x to the 4th. And then you'd have a bunch of other stuff. Maybe the next term would be a minus something, x cubed. Okay, but what's going to happen is this term's going to dominate. So it's going to dominate the other terms that are lower powers of x. So that limit's going to be infinity. And likewise, as you go to negative infinity, you're also going to get it's going to that. And this is all because x to the 4th dominates. If you expand it out, x to the 4th dominates. So whatever x to the 4th does as x goes to infinity, that's what the whole function is going to do overall. And so as you go to infinity, this goes to infinity. As you go to negative infinity, this goes to infinity as well. So that means that this is what's going to happen. That they're going to go up. Okay, so these are wrong there. So that graph's out. And this is it right here. This is going to be the graph. Okay, so notice that I didn't use all of the different concepts. I didn't take any derivatives or anything. And that's just like, look at the easiest ones that you can do, which was these intercepts, and kind of look at the asymptotes kind of idea. Whereas, but it wasn't like a horizontal asymptote. It was more just like what's happening as it's going to infinity or negative infinity. That just determined, that's going to determine most of them. Okay. Another thing we could have done is find the Y-intercept, but that's already going through, it's already right there. So, okay, let's go to the number 2. Okay, so here we have x minus x squared over 3 minus that, okay, minus 4x plus x squared. Okay, so for this one, what you want to do is factor it. So it's x times 1 minus x in the numerator, and the denominator, that's x squared minus 4x. I'm going to write it like this because then I can see it better to factor it. Now, out of the numerator, I'm going to take, I want to have this x coming first. So if I factor a negative out, then I get x minus 1 like that. Okay, and then in the denominator, I can factor that as well. And that's going to give me x minus 1 and x plus 3. Okay, now these are going to cancel. Okay, and which would leave you with this. However, because this is in the denominator of the original function, I can't plug 1 into the original function. So this is because it canceled like that, I'm basically going to have this graph, except there's be a hole at x equals 1. When x equals 1, there's going to be a hole in the graph. Okay, so that would be like this right here. You'd have something like that, or like that, or like that, or I think is that at 1? Oh yeah, so they're all at 1. So that's incorporated into all of the graphs. Okay, so no matter which one it is, we're fine. Okay, so now at this point I have this still, right? And maybe the easiest thing would be what is the Y-intercept? Okay, so let's do that in red. So Y-intercept. And that would just be f of 0. So which is going to be putting a 0 into here. And that's going to be 0. So it's going to go through the origin. Okay, so I just look through all of them that go through the origin. Okay, they all do, it looks like. Okay, so that didn't eliminate anything. Next thing, let's look at asymptotes. Okay, let's look at vertical asymptote. That's going to be at -3. Okay, so if you set that equal to 0, you get -3. Okay, so there's going to be a vertical asymptote at -3. Okay, so that's fine. This one's at +3, so wait a minute. I made a mistake. I made a terrible mistake. This should be minus. All right, my factoring skills are off. Okay, that should be minus. So actually, then that means that the vertical asymptote is at +3, which means that this one's out, and this one's okay. This is out. This is not -3, and this is out. No, that's okay. Okay, so then those are negative. Those are both at -3. So those two graphs are out of the picture. Okay, eliminated by that. Let's go with the next thing. Okay, now if you take the limit as x goes to infinity of f of x, we have the limit as x goes to infinity of -x over x minus 3. Okay, and that's going to be -infinity. No, what am I doing? All kinds of mistakes. That's -1. Okay, and so that's going to be this one here. This has a horizontal asymptote at -1, and this has a horizontal asymptote at +1. So that's out. Okay, so that one can't be it. Has to be this graph. But let me show you one more thing, which you would probably go to next, and that would be investigating this vertical asymptote. Okay, so the limit as x approaches 3 from the right, what's going to happen? So you have -x over x minus 3. Okay, so now as you go to As you go to 3 from the right, that means you're approaching through values that are greater than 3. So like 3.1, you take 3.1 minus 3, you get positive 0.1. And then you have a 3.1 up here. So this is positive. This is negative. You have negative. But then you have a positive. And then down here, it's going to be positive as you approach from the right, because you're approaching through values that are greater than 3. So something greater than 3 minus 3 is going to be positive. So that's negative. You're going to get negative infinity as you approach from the right. Okay, so as you come from the right, it's going to negative infinity, like that. So that's what that is. Okay, as you come in from the left, then again here, you're coming to 3. So and 3 is a positive number, so that's going to be positive. But down here, you're coming through values that are less than 3. So like 2.9. Take 2.9 minus 3, you get a negative number. So that's going to be negative. Those negatives are going to cancel, and you're going to go to positive infinity. Okay, so that's what. So that is. Let me get a different color here. Let's try that one. Okay, so that's going to positive infinity. So that means you're going up like that. Okay. So at any rate, this is going to be the graph right here. But I think with all that information I just gave you, you can kind of tell what happened. You could probably come up with this on your own. Okay. Okay, so let's look at number 3, sorry. Okay, so number 3, sketch fx equals x squared over x squared plus 3. Okay, there's no vertical asymptotes because this doesn't. There's no real number that makes the denominator 0. So that's and the denominator is always greater than equal to 3. So it's always positive. It's never 0. Okay, so let's take the limit. Let's try the as x goes to infinity. That limit's going to be 1 because the highest order term is x squared in the numerator and x squared in the denominator. So it's just going to be the coefficients of those. And also the limit as x goes to negative infinity of that is also 1. So those are both there. Okay, so you're going to have a horizontal asymptote. Y equals 1 will be a horizontal asymptote. Okay, so that one has it right there. This one's at 3, so that's off. This one doesn't have it. We should have a horizontal asymptote. That doesn't have it. This one has it. Okay, so that means that these two answers are eliminated. Okay, now next thing would be intercepts. Those seem to be easy to do. So if we're going to go with the Y-intercept, it's just f of 0 is, let's say, 0 squared over 0 squared plus 3. That's going to be 0. Okay, so it's going to go to the point 0, 0. So you look for the graph. That goes to a 0, 0 right there. And this one doesn't. So that means this graph is out. And this is the only graph it can be. Okay. So let's move on to the next one. Number 4. Sketch y equals x times the tangent of x. Okay, so this is interesting. Let's try the Y-intercept. So, and that means you set x equal to 0. So y is equal to 0 times tangent of 0. And tangent of 0 is also 0, so this is like 0 times 0. This is just 0. Okay. So this one works, and that one goes to 0. This doesn't, and that doesn't. Okay, so that means those two are out. Okay, so now, in both these cases, you can tell that pi over 2 is a vertical asymptote in both these graphs, but it's because of the tangent part. So let's take the limit as x approaches pi over 2 from the right of x times tangent x. No, not from the right, from the left. Okay, because we want to know what happens as you go this way to pi over 2. What happens? Not as you come this way, because this is not part of, that's not illustrated in the graph. So coming from the left. Okay, so tangent x is, okay, so if you have, so this right here going straight up, that's pi over 2. So this angle is pi over 2. Okay, so what happens to tangent? Tangent is the opposite over the adjacent, right? Now, as this goes this way to pi over 2, then this is going to go to 1, and that's going to go to 0. Okay, so that's going to infinity. But in the first quadrant here, which is where we're approaching from, tangent is always positive. X is always positive too, because it's between 0 and pi over 2. So those numbers are all positive. So that means that's going to go to infinity, okay, which is going up that way. So that's wrong, because it's got to come up this way. That means this graph is all wrong. Now, as you go to negative pi over 2 from the right, which would be going this way, maybe I do it in this color. Maybe as you're going this way, then what's happening there is you got this angle down here. And again, y is negative, but x is positive. Okay, so as you're going this way, this is actually going to negative infinity. That's negative, and this is also negative, because x is negative values right here. So it's also going to be positive infinity. Okay, so that's also going to be what happens. Okay, so it's going to be this first graph right here. Okay, so let's check out number 5. 3 over 1 plus e to the negative x. Okay, so here, okay, so here, what we want to check right here first is what happens as x goes to infinity. Okay, so as x gets larger and larger, you're taking e to the negative larger and larger. That's going to go, this is going to go to 0. Okay, and so you're just going to end up with 3. So 3 is a horizontal asymptote as you go to the right. Okay, so that's going to be like this, and this one is this and this are good. Now over here, it should be coming over, it should be approaching 3 as you go to the right. So that means that both these two are out. Okay, now as you go to, wait a minute, this is 6. Okay, so I take that back. This is 6. It should be 3. It should be going this way, right here. It should be going to that. So that one's out too. Okay, but let's take the limit that goes to negative infinity. And what happens here is this term, instead of going to 0, this is going to go to infinity. But essentially, you're going to have like 3 over infinity, which is going to be 0. Okay. And so over here, you're going to 0. So this is fine right here. This is going to 0 right here. Another thing that's good to calculate here would be the Y-intercept. That's the easiest thing to calculate. So f of 0 is 3 over 1 plus e to the 0, which is 3 over 1 plus 1. So e to the 0 is 1. So that's 3 halves. Okay, so it's going to go through the point 0, 3 halves. And that is right here. That's 1.5. So 0, 3 halves right there. Okay, so this one checks all the boxes, and this is what it looks like. Okay, this is known as a logistic function, by the way.